Welcome. I'm going to talk about analytic trig, the tangent sum and difference identities. So the highlight down here in green, we got tangent of some angle A plus some angle B. It's going to equal this guy on the right. Tangent of angle A minus angle B is going to equal this guy on the right. A couple things to notice here. Tangent of A plus B, plus in the numerator, subtraction in the denominator. Tangent of A minus B, subtraction in the numerator, addition in the denominator. So notice the pattern there, okay? Let's try some examples. Okay, we got tangent of 17 pi over 12. We have to break that 17 pi over 12 into angle measures in radians that we have memorized in the unit circle, so they're easy to give an output, find the value of tangent at this angle. So I got tangent equals 7 pi over 6. My 6 is kind of sloppy, sorry. Plus pi over 4. We're going to rewrite that using the identity. So it's tangent of the first angle plus tangent of the second angle. Now here's my favorite part, fractions. Let's go. 1 minus, now the opposite operator. See, the operator here is addition. It's not opposite, sorry. Inverse operation here is subtraction. So that goes down there in the denominator. And then we just have tangent of the first angle times tangent of the second angle. Let's go ahead and replace these values with values we know. So tangent 7 pi over 6, that's going to be, that's negative radical 3 over 2 over, whoopsie daisy, over 1 over 2. And that's going to be plus, I know tangent of pi over 4 is 1 because it's radical 2 over radical 2. And I get 1 minus, I think I got this one backwards. Don't make my mistake. Or if you do, make sure you catch it. I put the sign in the denominator. My bad. Cosine goes in the denominator. And I get 1 minus, well, I already know the value of 7 pi over 6. That's negative, that's 1 over 2 over negative radical 3 over 2, rather, times 1. Okay. Now let's simplify this one. So I get negative 1 over radical 3 plus 1 over 1. These cancel. Minus 1 over radical 3. Yeah, but that's minus a minus, right? So that actually becomes a plus. Okay. We can rewrite this without irrational numbers in the denominator. So let's do that. So I get negative 1 plus radical 3 in the numerator, and I get radical 3 plus 1 in the denominator. Final answer, cannot factor, not going to worry about it. We're going to leave this in the form that it is. This actually is mathematically correct. If we wanted to get rid of this, we could rationalize the denominator by multiplying times its conjugate. We just reorder this here because this is, I could rewrite this as 1 plus radical 3. Order does not matter. Okay. So we need to do that, but we don't need to. This is mathematically accurate. And the focus here is analytic trig, not rationalizing fractions. I'll leave that for you to do. So now we're going to use a difference example, a difference identity for tangent. So tangent of 5 pi over 12, I'm just going to rewrite that as tangent of 2/3 pi minus pi over 4. That would give me 5 pi over 12. Let's rewrite this using the identity now. So I have tangent of the first angle minus, right, because this is a difference inside here. So I use a difference over there. Okay, and then I'm going to have tangent of pi over 4, tangent of the second angle, fractions 1 plus. So remember from our tangent sum and difference identities, the math operator in the denominator is going to be the inverse of the operator that's inside the parentheses here. Okay, inside the parentheses matches in the numerator, and then it's the inverse in the denominator. Just as a reminder, and tangent of 2 pi over 3 times tangent of pi over 4. Now we just replace these guys with values that we know from the unit circle. So tangent of 2 pi over 3, that's a sine of radical 3 over 2 over 1/2 for cosine, minus tangent of pi over 4 is just 1. And then I get 1 plus tangent of 2/3 pi. I already know what that is. I wrote it in the numerator. Times tangent of, that's 1. So let's simplify these fractions here. And I get radical 3 minus 1 over 1 plus radical 3. Final answer. This is mathematically correct. There's nothing else I'm going to do here. I don't feel like doing anything here. We could simplify, I suppose, in the numerator, but nope, I can't do that either, because if I try to simplify by factoring out a negative 1, I now get 1 minus radical. That's not the same. So we could multiply by the conjugate, right? And that's not what we're going to do today. This is for another time. That's up to you to do. I hope this was helpful for the tangent, sum, and difference identities. It's just, these are just tools we use, other than trig tables and calculators, to find values at angle measures for angles we don't have memorized on the unit circle. And there's also later on other ways we can use these identities, sine, cosine, and tangent, sum, and difference identities, to simplify some trig equations and expressions. Hope this has been helpful. If you need any help, you know how to get a hold of me.